Hello dear students, I'm P. Madhura, lecturer in physics in continuation of video lectures. Now, expression for strain energy. Strain energy. So what is strain energy? So it is the work done in deforming a body against inter-atomic forces. Forces is stored in the form of potential energy, which is called as strain energy. Now, strain energy equation can be written, or elastic potential energy, it also called as elastic potential energy or strain energy, can be written as half into stress into strain into volume. Strain into volume. Half stress into strain into volume. Now let us consider a wire of length L, area of cross section A, and F is the force applied. Okay. Now x is the elongation, we assume. X is the elongation. Now we have formula y is equal to F into L by A into, we will take x is the elongation. Now F is equal to YAX by L. Now to further elongate the wire through a distance of dx, some work is to be done. dW is equal to F dx. Now if you apply the limits here, we will take small x here. Here x is the elongation, small x. And further elongation dx, if you take now, YAX by L into dx. We will integrate both. Limits are 0 to x only. Now integration formula, integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. And limits f of x a to b, upper limit minus lower limit will take. This is these two formulas we are using here. Now dw integration is w, f dx f a into by L into x square by 2 we have. Now this work done is nothing but potential energy, elastic potential energy u you can take, and here y a by L x square by 2. We multiply and divide with L here. Multiply and divide by L. So if you divide and multiply with L now, what do you get here? Here y a by L x by L into y x 2 times is there now, x by L into, here you are multiplying dividing now, here multiply and divide. So here L square down is there into a into L. Now if you closely observe this is y into change in length by original length, that is strain. So you know y is equal to stress by strain. Now in this y into strain is nothing but stress. Y into strain is equal to stress. Now x by L is strain. X by L is strain. Next L, A into L. A into L is volume. Now what you need to write here in place of this, these formulas are separate here. Now in case of U, potential energy, we can write here 1 by 2 L, here 1 by 2 is there. 1 by 2 y into x, that is half into stress into strain into, last what you have got, volume. The required equation come up now, or strain energy per unit volume also you can write half into stress into strain. Here you observe YAX, you are dividing and multiplying with L here. Then YA by L, AX by L, one time you write, This x you take separate, x by L, L into A. So half stress by strain. Stress is equal to y into strain. So x by L is stress is equal to y into strain. The replace here. Y into strain is stress. And strain is change in length by original length is strain. Area into length is volume. So total equation, potential energy, elastic potential energy or strain energy, U is equal to half into stress into strain into volume. This is the required equation. Thank you.